Today we'll be looking at graphs and error bars. So let's commence operations. So to understand what we're going to be doing today, we have to choose an experiment to investigate. What is the density of water? So that's the experiment. Now, if you recall, density involves mass and volume. So here are our two devices, that will be used to measure density. We have a graduate cylinder that will be used to measure volume. We have a scale that will be used to measure mass. The division of the two will give us density. So I've created some made-up data here. We have mass, we have volume. And notice I have included this plus or minus. On a balance, typically, if the balance has 1 decimal point, then the plus or minus is 0.1. What does this plus or minus 0.1 mean? It means when the balance registered 1.2 grams for the mass, it could be as high as 1.3. 1.2 plus 0.1. It could also be as low as 1.1. 1.2 minus 0.1. Notice for the graduated cylinder, our graduated cylinder here, the uncertainty is greater. It's half a mil. What does this half mil mean? It means that when we measured 1 milliliter of water, it could have been as high as 1.5 milliliters, or it could have been as low as half a milliliter. That's what that plus or minus means. It's what's called the uncertainty or the error in an experiment. It's not really an error. I prefer the word uncertainty, but it's also called experimental error. Sometimes it's called absolute error. It goes by many different names. Now, when the uncertainty or the absolute error is always the same, you could just include it in the heading of the table. Now, if it changes, you can't do that, but if it's always the same, you could just include it in the heading, as you can see here. So you don't have to write out plus or minus 0.5 for every data point, just include it in the heading. So we have our graph here. Mass is on the y-axis, volume is on the x-axis. Notice the unit, milliliter and gram. And notice we're going up by increments of decimal 1 on the x-axis and, in addition, decimal 1 on the y-axis. So let's look at our first point. 1.0 milliliters is around here. 1.2 grams is up here. We go across and down, and voila! There's our first data point that we have plotted. It's hard to see, I know, but it is there, right over there. All right. The question is, how do we represent this uncertainty, this error? Well, it's called an error bar. So let me explain. We start off by looking at volume. The volume measurement is 1.0, give or take 0.5, plus or minus 0.5. This means that the volume could have been as low as 0.5 or as high as 1.5. So all we do is draw a line. And that's shown here. Notice, where does the line begin? It begins at decimal 5. Decimal 5. 1 subtract decimal 5. Decimal 5. Where does this line end? It ends at 1.5. Why 1.5? Well, 1 plus 0.5, or 1.5. Now, typically at the end of the line, you have these mini lines drawn. The height of those mini lines are very small usually. very small. Actually, it doesn't really matter, but they should be fairly small. So there's our error bar in the x direction. And this error represents, or this error bar represents, the uncertainty of the experiment. What it really means is that when we say we measured 1 milliliter, we could have measured anywhere between half and 1.5. That's what it really means. Based on the measuring device we were using, the best we could say is that our measurement fell somewhere between half a milliliter all the way to 1.5 milliliters. Next, we want to focus on the error bar in the y direction for our mass. Notice it's 1.2 plus or minus 0.1. What does this mean? Well, it means it could be as low as 1.1 grams or as high as 1.3 grams. So I've drawn a line. Where does that line begin? Well, it begins at 1.1, as you can see, and it ends at 1.3. Once again, I create two other lines. Those lines can be very small. And there's our error bar for the first error bars for the first data point. And you would do this for all the other data points in the graph. So what does this line mean? It means that the best you can say in this experiment, given the balance that you were using, is that the mass is somewhere between 1.1 grams and 1.3 grams. The best you can say in this experiment, based on the graduated cylinder you were using, is that the volume was somewhere between half and 1.5 mils. That's what these bars mean. They're trying to give you a visual representation of the uncertainty or the error or the absolute error in this experiment.